Hi everyone, in this video we are going to discuss about how to calculate the trigonometric ratios of angles like 270 degree minus theta, and this is obviously a reflex angle, and here we are going to learn how to find the trigonometric ratios of such reflex angles in terms of the trigonometric ratios of the theta angle. So we will always take theta as an acute angle, that's the base angle, and we will try to express the trigonometric ratios of the reflex angles in terms of the trigonometric ratios of an acute angle theta. From the concept of unit circle and trigonometric functions, we know that if we have a point P on a unit circle whose coordinates are x, y, then x represents the cosine function of theta. So cosine of theta would be equal to x, and y represents the sine function of theta. So sine of theta would be equal to y. And in this diagram, I have also noted that x would be equal to OA, the distance of A from the origin, and y would be equal to AP, the distance of P from the point A. Now let me plot a point Q on this unit circle where OQ will create an angle 270 degree minus theta with the positive x-axis. So I have plotted a point Q on the unit circle here, and OQ is creating an angle 270 degree minus theta with the positive x-axis, and that I have denoted that with the yellow arc there, right? So in that case, can you think about what would be the value of the angle BOQ? Well, that angle will be equal to theta degree, because you see, if you take the entire 3 quadrant of this angle, that would have been 270 degree, but I had to plot Q in such a way that OQ would create theta degree less than 270 degree. So that means this little angle right here, the angle BOQ must be theta degree. Then only the angle, let's say AOQ, the big angle, right? That big angle would be 270 degree minus theta. And now let's look at these two little right triangles here. The first one is OAP, that is a right triangle because AP is perpendicular on x-axis. And similarly, the triangle OBQ, that is also another right triangle because BQ is a perpendicular on the negative y-axis. Now for these two triangles, as you can see, their hypotenuse is of equal length because OP and OQ, they are of the same length. By the way, that is equal to 1 unit because it's a unit circle, and OP or OQ, it is nothing but the radius of this circle. So OP is equal to OQ, and then if you think about the angle APO, that angle would be 90 degree minus theta, because for a right triangle we already have one angle which is 90 degree, another one is theta, so the remaining angle would be 90 degree minus theta. And the same logic applies to the triangle OBQ. There also the angle BQO or the angle OQB, the same angle, I'm just using two different names. So the angle OQB, that angle would also be 90 degree minus theta because that is also a right triangle there. One angle is theta, so the remaining triangle would be 90 degree minus theta. Now you see, we have two triangles where they have one side of same length and the two adjacent corresponding angles are also of the same size. So that clearly indicates that these two triangles would be congruent triangles. They are actually identical triangles. So can we write it like this? So I have noted here that the triangle OAP would be congruent to the triangle OBQ, and then their corresponding sides will be of equal length because they both are congruent triangle now. So from that concept, we can say that AP will be equal to BQ. I'm just talking about the absolute length. I'm not considering the signs yet, but if you just think about the distances, just absolute distance, then AP will be equal to BQ, and similarly OA will be equal to OB, and we already know that OP and OQ are equal because they are the radius of this unit circle. So now let's try to find out what would be the x coordinate of the point Q. As you can see, Q is actually a point in the third quadrant. That means its x coordinate as well as the y coordinate, they both will be negative. That is why I have left an empty parenthesis there, but I have put a negative sign to denote that the x coordinate will also be some negative value and the y coordinate will also be some negative value. That is why I have intentionally written the negative sign there, but I have not written any specific value yet, and that's the blank we are going to fill in now. From the concept of trigonometric functions, we know that the x coordinate of a point on the unit circle is represented by the cosine of the angle that OQ would create with the positive x-axis, right? So here in this particular example, then we can say, okay, the x coordinate of Q would be equal to cosine of 270 degree minus theta. So let me write it down. So I have noted that the cosine of 270 degree minus theta would be equal to the x coordinate of Q, and that's exactly what we are trying to find out, right? Now what would be the x coordinate of Q? The x coordinate of Q would actually be the length BQ. That length would represent the x coordinate of the point Q, the BQ length, right? However, we have to also carefully remember that this will be a negative value, because if we say BQ, yes, that is just an absolute value of that one side of the triangle, but because we are talking about a point in the third quadrant, the x coordinate will also be negative. So can we write it as negative of absolute value of BQ? And now we also know that BQ is equal to AP. So can we say that, okay, this will be equal to negative of absolute value of AP? And also we know that AP is actually nothing but sine of theta. As you can see up there, I'm doing an underline there. So AP is actually equal to sine of theta. So can we say that then this will be equal to negative sine of theta? And also sine of theta is nothing but the y coordinate of the point P. So this will also be equal to, so I am going to write it right here. We can also say that this will be equal to negative of y. So from here we have gotten two things. The first thing is that the cosine of 270 degree minus theta, and that is equal to negative of sine theta. And also we have found the x coordinate of the point Q, and the x coordinate value is actually negative of y. So I am going to write it here as negative of y, and it's going to look like this. So far we have filled in the blank for the x coordinate of Q. Also let me make a quick note here. So that is the first result, which is cosine of 270 degree minus theta is equal to negative of sine theta. Now let's try to calculate the value of sine of 270 degree minus theta. And if you think about the y coordinate of the point Q, the y coordinate would actually be the sine of 270 degree minus theta, because that is the angle that OQ makes with the positive x-axis. And from the concept of trigonometric function in unit circle, we know that the y coordinate is actually represented by the sine function of that angle. So here sine of 270 degree minus theta would represent the y coordinate of the point Q. So let me make a note. Now what would be the y coordinate value of point Q? Well, that would be the distance OB. However, that would be in the negative y axis direction. So it will be a negative value, but it will be same as negative of the absolute value of OB. And also we know that OB is equal to OA. As you can see right here, I'm doing a green underline there. So OB is equal to OA. So can we say that this will be equal to negative of absolute value of OA? And then what is the value of OA? Well, if we look up there, OA is actually equal to cosine of theta, which is also equal to positive x. So now here I am going to use these two values. So OA is actually, so the negative sign will remain as is, and OA will become cosine of theta, and that is also going to be equal to negative of x. So here we have found two things. We have found the trigonometric ratio of sine of 270 degree minus theta, which turns out to be negative of cosine of theta, and that is also equal to negative of x. So we have found the y coordinate of the point Q, which is negative of x, and I'm going to write it right here. So this becomes negative of x, that's the y coordinate. So we have filled in both the blanks there. So now we know exactly what are the coordinates of the point Q in terms of the coordinates of the point P. So if the coordinates of point P are x, y, then the coordinates of point Q would be negative y, negative x. And here for the value of sine of 270 degree minus theta, that will be equal to negative of cosine of theta. So let me make a quick note. Now let's try to calculate the value of tangent of 270 degree minus theta. We know that tangent is the ratio of sine to cos. So that would be sine of 270 degree minus theta divided by cos of 270 degree minus theta. And then what is the value of sine of 270 degree minus theta? Well, that is actually equal to negative of cosine of theta. So can we write it as negative of cosine of theta? And also what is the value of cosine of 270 degree minus theta? Well, that is actually equal to negative of sine of theta. So can we write it as negative of sine of theta? And then as you can see, the negative one in the numerator and the denominator, they will cancel out each other, and then we are going to be left with cosine of theta divided by sine of theta, that is actually cotangent of theta. So this is nothing but cotangent of theta. So let me make a quick note. Now let's try to calculate the reciprocal ratios, which are cosecant, secant and cotangent. First we are going to start with the cosecant of 270 degree minus theta. We know that cosecant is the reciprocal of sine, so we can write it as 1 divided by sine of 270 degree minus theta. And now what was the value of sine of 270 degree minus theta? Well, that was actually negative of cosine of theta. And then we also know that the reciprocal of cosine is actually secant, so this should be negative of secant of theta. So let me make a quick note. Next, let's calculate the secant of 270 degree minus theta. we know that the secant is actually reciprocal of cosine. So we can write it as 1 divided by cosine of 270 degree minus theta. And then what was the value of cosine of 270 degree minus theta? That was actually negative of sine of theta. And we know that 1 divided by sine of theta, that's the reciprocal of sine of theta, that will be cosecant of theta. So this will be negative of cosecant of theta. So let me make a quick note. So now we are left with the last one, which is the cotangent of 270 degree minus theta. So let's quickly derive that. We know that cotangent is the ratio of cosine over sine, or cosine to sine. That's the ratio. So we can write this as cosine of 270 degree minus theta divided by sine of 270 degree minus theta. And then what was the value of cosine of 270 degree minus theta? That was actually negative of sine of theta. And then what was the value of sine of 270 degree minus theta? That was actually negative of cosine of theta. Here you can see that the negative 1 in the numerator and the denominator, they will cancel out each other. So we are now going to be left with sine of theta divided by cosine of theta. That would be tangent of theta. So this is positive tangent of theta. So let me make a quick note. So we have completed the derivation of all of the trigonometric ratios for the angle 270 degree minus theta in terms of the trigonometric ratios of the acute angle theta. I hope everything made sense. Thank you for watching. See you in the next video.